Now, before I move on to the last section, I want to pay tribute to an unlikely character in a talk about neuroscience, which is Ernst Gombrich. Ernst Gombrich was one of the foremost historians of art of the 20th century. And it turns out that Gombrich's approach to understanding art had a lot in common with ideas in the Bayesian brain, and more specifically with the idea that perception is largely an act of imagination or construction on the part of the perceiver. And this is most apparent in his concept of the beholder's share, which emphasizes that the viewer brings an awful lot to the table in the act of experiencing an artwork. So he had this to say in his 1960 book, Art and Illusion. The artist gives the beholder more to do. He draws him into the magic circle of creation and allows him to experience something of the thrill of making, which had once been the privilege of the artist. And I think for me this is very powerful when looking at especially things like Impressionist art. And here, one way to think about this is that the artist has reverse engineered the whole perceptual process so that what's there are not the objects, the endpoints of perception, but rather the raw materials, the patterns of light that engage our perceptual machinery in doing its work. And for me, this might be why paintings like this are particularly powerful. Now, the final dimension of consciousness I want to talk about is conscious self. The fundamental experience of being someone like you. There are many aspects to our experience of being a conscious self. There is the bodily self, the experience of being and identifying with a particular body, a bit of the world that goes around with you in the world all the time. There's the perspectival self, the experience of seeing the world or experiencing the world from a particular first-person perspective, usually somewhere in the body, but not always. There's the volitional self, the experience of intending to do things and of making things happen in the world, of agency. And these ideas are, of course, often associated with concepts of will. Then there's the narrative self. This is where only until now we don't have to worry about the concept of I, but when we get to the narrative self, there is now an I. There is a continuity of self-experience from hour to hour, from day to day, from month to month, and from year to year, that you associate a name with, and a particular set of autobiographical memories. And finally, there's a social self. The way I experience being me is partly dependent on the way I perceive you as perceiving me. I'm just going to talk in the minutes that remain about the bodily self. This is something we're working on quite a lot in Sussex. The experience of identifying with and owning a particular body. And the basic idea I want to convey is, again, very simple. It's just that we should think of our experience of body ownership in the same way that we think about our experience of other things as well. That is, it's the brain's best guess of the causes of body-related signals. And the brain is always making this inference. It's making its inference about what in the world is part of the body and what is not part of the body. But it has access, in this case, to other sorts of sensory signals, not just visual signals or tactile signals, but also proprioceptive signals, the orange arrows here. These inform the brain about the body's configuration and position in space. And then also, and often overlooked, are interoceptive signals. These are signals that originate from within the body, that tell the brain about the physiological state or condition of the inside, of the internal physiological milieu. And you can think, the idea is that our experience of embodied selfhood is the brain's best guess of the causes of all these signals put together. That's just to emphasize interoception. An important part of this idea is that interoception, the sense of the body from within, should work along the same principles, the same Bayesian principles that we've been thinking about vision and audition previously. That is, our experience of the inside of our bodies is the brain's best guess of the causes of the signals that come from the inside of our bodies. So we can think of, again, top-down predictions, carrying predictions about what the bodily state is like, and bottom-up prediction errors that report the differences between what's going on and what the brain expects. So what is our experience of the inside of our bodies? Well, way back at the beginning of psychology, William James and Carl Langer proposed that emotional experience, was really about the brain's perception of changes in its physiological state. rather than perception of the outside world. So in this classic example, seeing a bear does not in itself generate the experience of fear. Rather, seeing the bear sets in train a load of physiological changes, preparatory fight and flight responses, and it's the perception of those bodily changes in the context of a bear being around that leads to our experience of fear. So the Bayesian perspective just generalizes that idea and says that emotional experience is the brain's best guess of the causes of interoceptive signals. And this fits very nicely with a lot of evidence, and this is just one study done by a Finnish group. And all they did here was they had people report where on their bodies they felt various emotions to take place. And so you feel anxiety in one part of your body, you feel fear in another, and so on. So our experience of emotion does seem to be intrinsically embodied. Now, another part of our experience of being a body is the body as a physical object in the world. And this might seem quite easy to take for granted, since our physical body is just always there. It goes around with us, it changes over the years in unfortunate ways, but it's always there. And but it would be a mistake to take our experience of body ownership for granted. And there are some classic experiments that demonstrate how malleable our experience of body ownership is. This is the famous rubber hand experiment. Probably some of you have seen this. What happens here is that a volunteer has their hand hidden under a table, and a fake hand is put on top of the table, and then both hands are simultaneously stroked with a paintbrush. And it turns out that just seeing a hand-like object where a hand might be, feeling touch, and then seeing that object being touched is enough evidence that the brain's best guess becomes that that fake hand is in fact part of my body, sort of part of my body. This is what it looks like in practice. Here you can see the fake hand, focusing on it. There's the real hand, not focusing on it, simultaneous stroking. And there are various ways you can test it. I found in doing this, it works even better on children, by the way, if you do that. So that's interesting because that's using visual and tactile signals to convince the brain that this object is part of its body. In my lab, we've been interested in whether these signals that come from inside the body also play a role. So we set up a virtual reality version of this rubber hand illusion where people wear these goggles and they see a virtual fake hand. And we also record their heartbeat. So now what we can do is we can make the virtual hand flash either in time or out of time with their heartbeat. And we ask the question, do people experience this virtual hand as more belonging to them when it's flashing in time rather than out of time with their heartbeat? And the answer is that it does. And this is just some data basically that bigger than that, which means that indeed they experience the hand as more their own. The way we measure that actually is that first we can ask them, that's the easiest way, but then we can also ask them to point to where they think their hand really is. And we can see how far they drift from where their hand really is to where the virtual hand is. And that provides a more objective way of measuring the strength of the effect. Here's what it looks like in practice. Again, I don't know if you can see this. That's the real hand. That's somebody's virtual hand. Again, imagine you're wearing a headset, so you'll see this in 3D. And you can just about see it pulsing to red and back, I hope. And you can also do some other things with these virtual reality rubber hands that you couldn't do with real rubber hands. For instance, you can map movements of the real hand to the virtual hand. So you can start to ask questions about the extent to which the virtual hand moves as I predict it to move. How much does that affect the extent to which I feel it to be part of my body? You can make it change color. So you can have somebody embody a skin color associated with a cultural outgroup and see if they become less racist as a result. And then my favorite is where you can change actually the size of the body, and that's coming up here. So here what we do is we can have the hand telescope up and down in size. And again, this might seem like fun, and it is fun, but there is a serious purpose. There are various conditions. There's in fact a condition called Alice in Wonderland syndrome, where people report that parts of their body are indeed telescoping up and down in size. And in a more subtle way, there are lots of body dysmorphias, of subtle misperceptions of body shape, which might be associated with eating disorders. And so these sorts of techniques allow us to approach in a very fine-grained way how people might misperceive their own bodies. So that brings me to the third take-home message about self. And with apologies to Descartes, the take-home message is that I predict myself, therefore I am.
Hello, I'm Allison. I have read a lot about neuroscience since 2003, and as fond of it. In 2016, I discovered a great novel on neuroscience, the unique book I'd like to share with you on this channel here for 3 reasons. 1. It shows you an original approach to neuroscience that has been never done before. 2. It's quite well written, you're totally captivating. That's an amazing thriller. And 3. It is based on a serious and true study about electromagnetic harassment. I highly recommend you this book entitled Neuroscience, Crime and Corruption, White Mind Distortion for 2 main reasons. 1. It deals with neuroscience in a totally different way as usual. The innovative form used is a novel. And I'm pretty sure that you have never ever read a novel about neuroscience, but articles and studies. The second reason is the quality of the book. Well, it's pretty good written and the story is captivating. You can click on the link here to know more about the story, which is a thriller. What I can tell you is I couldn't help myself reading when I started. I was so in. The characters are incredibly amazing, and the story is so unbelievable. What an experience. So if you want to know more about this book, and I think I'm gonna make more videos like this, just click here. Thank you for watching. Don't forget to like and share this video. Bye.